A car door slams shut in a scrapyard in Ohio. Within 6 months, that same piece of metal could be holding up a skyscraper, or wrapped around the hull of a container ship, or reinforcing concrete 100 stories in the air. That is strange enough on its own. But here is the part that should really stop you. Some of the strongest, most demanding steel on Earth, steel rated for bridges and pipelines, and military-grade equipment, starts its life as garbage. Not iron ore dug fresh from a mountain. Garbage. Crushed cars, dead refrigerators, torn apart washing machines. Why would anyone trust the backbone of modern infrastructure to scrap metal? Shouldn't the strongest materials come from the purest sources? And yet the opposite is true. Some of the toughest steel alloys on the planet are built almost entirely from what we throw away. To understand why, you have to follow that scrap metal on its actual journey, because the transformation from junk to high-performance steel is one of the most oddly satisfying industrial processes on Earth. It starts with sourcing. Scrapyards across the country collect end-of-life vehicles, appliances, demolished steel beams, and industrial offcuts. But not all scrap is equal. And that matters more than people think. Mills grade incoming scrap by purity. Because contamination, things like copper wiring, plastic trim, or aluminum fixtures, can weaken the final alloy if it isn't removed. So before anything gets melted, the material goes through sorting. Powerful electromagnets pull ferrous metal away from non-metallic debris. Shredding machines tear car bodies and appliances into fist-sized chunks. And optical sensors and eddy current separators sort out the aluminum, copper, and plastics that don't belong. A single processing plant can shred and sort over 100 tons of scrap metal per hour. That is how much material is moving before a single furnace even turns on. Once the scrap is cleaned and graded, it moves into the core transformation stage, and this is where things get genuinely dramatic. The sorted steel scrap is loaded into an electric arc furnace, a massive vessel lined with refractory brick. Enormous graphite electrodes lower into the chamber and strike an arc, essentially controlled lightning, generating temperatures that can exceed 1800 degrees Celsius. At that heat, solid scrap metal doesn't just soften. It liquefies, collapsing into a churning pool of molten steel in under an hour for a full furnace load. That is the first shock. The second is what happens next. Once the scrap is fully molten, technicians inject precise amounts of alloying elements, chromium, nickel, manganese, depending on what kind of steel is being made. This is where garbage becomes engineered material. The furnace operators aren't guessing. They are calibrating the chemical composition down to fractions of a percent, because a tiny shift in carbon content can be the difference between steel that bends and steel that snaps. After alloying, the molten steel is transferred to a ladle for secondary refining, where impurities like sulfur and excess oxygen are stripped out through a process called ladle metallurgy. Once the chemistry is locked in, the steel is continuously cast, poured into molds that shape it into slabs, billets, or blooms, as it cools and solidifies in a controlled, gradual sequence. After that, the semi-finished steel moves into finishing. This is where shape and strength get locked in for good. The slabs or billets pass through rolling mills, massive rollers that compress and stretch the steel under extreme pressure, some operating at forces of several thousand tons, squeezing the material into sheets, beams, or bars depending on its final use. At this stage, the steel is often hot, sometimes above 1000 degrees Celsius, and rolling it while hot allows the internal grain structure to align. That is a major reason recycled steel can end up just as strong, sometimes stronger, than steel made from raw ore. Once shaped, the steel is cooled under carefully controlled temperature conditions, because cooling too fast or too slow changes its hardness and flexibility. Then comes quality inspection. Technicians run ultrasonic scans and tensile strength tests to check for internal flaws invisible to the eye. Only steel that meets strict industry standards gets stamped, graded, and cleared for shipment. From there, it is cut, coiled, or bundled, and sent into the supply chain, on trucks, trains, and cargo ships, headed toward construction sites, shipyards, and factories around the world. So the scrapyard car door really can become skyscraper steel. But here is the complication nobody puts on the brochure. Electric arc furnaces, for all their brilliance, are incredibly energy hungry. Melting scrap at those temperatures draws enormous amounts of electricity, and depending on where that electricity comes from, the process can still carry a heavy carbon footprint, even though it avoids the mining and ore processing emissions of traditional steelmaking. That is the tension. Recycled steel is dramatically better for the planet than steel made from raw iron ore, but better doesn't mean clean. It just means less bad. And the scale of this industry is almost impossible to picture. Roughly 700 million tons of steel scrap get recycled globally every single year. That is the weight of over 60,000 fully loaded aircraft carriers, made entirely from stuff people threw away. In the United States alone, steel is one of the most recycled materials on Earth. More than paper, more than plastic, more than glass. Combined. Every minute, somewhere in the world, a furnace like the one we just walked through is swallowing scrap and turning it into structural steel. But there is a hidden cost most people never think about, and it isn't environmental. It's chemical. Certain trace elements, particularly copper from wiring and electronics, are almost impossible to fully remove from scrap steel. Too much copper contamination, and the steel becomes brittle at high temperatures, a defect engineers call hot shortness. As global scrap supplies get reused again and again, cycle after cycle, that copper contamination slowly accumulates. Some materials scientists genuinely worry that in the coming decades, the world's easily recyclable scrap pool could become measurably harder to purify, forcing the industry to blend in more virgin ore just to keep quality standards intact. So recycling steel isn't a permanent, endlessly repeatable magic trick. It is a resource with its own quiet expiration curve, one most people never hear about. Which brings us back to that car door. It gets crushed, shredded, melted at temperatures hotter than lava, alloyed with surgical precision, rolled under thousands of tons of pressure, and shipped out as some of the strongest material humans build with. And yet the very system that makes this possible is running on a resource that is subtly degrading with every cycle. We've built an entire civilization on the assumption that we can keep melting down our past to build our future. The real question is how long that assumption holds. If this kind of hidden industrial process fascinates you as much as it fascinates me, make sure you're subscribed. Because we break down how the world actually gets built, one process at a time. Drop a comment and tell me what everyday object you want us to trace back to its raw materials next. And if you learned something today, hit like. It genuinely helps this channel keep making videos like this one.